Hi students, this is 12.2 notes. Newton's first law: objects at rest tend to stay at rest, and objects in motion tend to stay in motion unless they are acted on by an unbalanced force. So a stalled car is going to stay at rest until you give it an unbalanced force to push it. Or when you hit the brakes quickly in your car, you will stay in motion because you were in motion with the car until your seatbelt gives you an unbalanced force and stops you. It's also called the law of inertia, which is the tendency of an object to resist a change in motion. Newton's second law: when an unbalanced force acts on an object, the object accelerates in the direction of the unbalanced force. Or what that basically is saying is it's saying acceleration is equal to force over mass. Objects with larger masses require larger forces to accelerate. So an example would be kicking a soccer ball versus kicking a bowling ball. A bowling ball, which is larger mass, will require a larger force to accelerate it. Or objects with larger velocities, this should say require, and this is larger, require forces to objects with larger velocities require larger forces to accelerate. For example, catching a baseball thrown by a person versus a baseball shot out of a cannon. It's a lot harder to decelerate the baseball shot out of a cannon, so it's going to require a larger force. So here is the equation, just rearranged from before. So force equals mass times acceleration. For this equation, force is always in newtons or N. Mass is always in kilograms or kg. And acceleration is always in meters per second squared. You do need to know how to rearrange this equation. So you might want to try and rearrange this equation. So this equation will be given to you on the test, but you do need to know how to rearrange it. If you wanted to solve for mass, you want to divide by acceleration on both sides, and that will cancel out your acceleration. So mass, I'll write it up here, mass is equal to force divided by A. Also, you need to know solving for acceleration. So if we have this equation again, to get rid of the mass now, you have to divide by mass on both sides. And so acceleration is equal to force over m. I will not give you the other two equations. I will not give you the ones that I'm boxing right now. You need to know those for the test. So what is the mass of an object that accelerates at 5 meters per second squared with a 32 Newton force is applied? First, you want to write the equation. We know this is a force, and this is an acceleration, and we're looking for mass. So mass is equal to force over acceleration. So you're going to take 32 newtons and divide by 5 meters per second squared. When you take 32 divided by 5, you get 6.4. The newtons and the meters per second, it's kind of hard to see how things cancel out, but remember I did tell you at one point that 1 newton equals kilograms meters per second squared. So the meters per second squared, when you divide that from the newtons, you actually do get kilograms. So what force is needed to accelerate a 200 kilogram object at 3 meters per second squared? This you want to use your force equals ma equation, and you will take your 200 kilograms times your 3 meters per second squared, and you will get 600 newtons. And what acceleration does a 3 kilogram object have if it was pushed with 975 newtons? You should pause and try to do this on your own. So acceleration is force over m. you would want to take 975 newtons and divide by 3 kilograms. When you take 975 and divide by 3, you get 325 meters per second squared. Weight and mass. Mass is the amount of matter in an object, whereas weight is a measure of the force of gravity in an object. Weight changes if gravity changes, whereas mass does not. So gravity is less on the moon, so you weigh less, but your mass will always stay the same no matter where you are.